In this section, we're going to discuss degradability. Another way to classify waste is based on degradability, which is the ability to be broken down. How long it takes for waste to decompose plays a huge role in the way that it is managed. Let's start with biodegradable waste, which is the most easily broken down. Biodegradable waste. Biodegradable waste includes any organic matter that can decompose into water, carbon dioxide, methane, or other simple molecules via a variety of natural processes. In the image, you see a pile of food scraps that is easily biodegradable, breaks down, and that composted material can often be added to soil when growing foods and other things. Food scraps, rotten vegetables, grass clippings, and other yard waste are all things that can be composted and used to enrich soil for farming. Food waste is a major source of waste around the world. Approximately 1/3 of the food produced ends up as waste. A lot of this waste takes place at the end of the food supply chain once the food ends up in people's homes. The United Nations estimates that the carbon footprint of wasted food is equivalent to 3.3 billion tons of carbon dioxide per year. This has a major impact on climate change, especially when food waste ends up in landfills instead of being composted. In landfills, biodegradable waste undergoes anaerobic fermentation, which releases methane gas and carbon dioxide. These gases are known as landfill gas and also greenhouse gas. They contribute to global warming and can also contaminate groundwater. Composting also releases methane gas and carbon dioxide, but since the waste is exposed to the air, it undergoes aerobic fermentation, generating less methane gas but more carbon dioxide. Carbon dioxide has less of an impact on global warming than methane, so composting is preferred to landfill. Non-biodegradable waste. Non-biodegradable waste includes items made of metal, glass, and plastic which will not degrade on their own. They do not break down by natural agents and can remain on Earth for thousands of years. How long does it take different materials to decompose in a landfill? A glass bottle takes 1 million years. Plastic beverage bottles, 450 years. Disposable diapers, 450 years. An aluminum can, 80 to 200 years. A tin can, 50 years. And leather, 50 years. The Great Pacific Garbage Patch consists of 2 areas of the North Pacific Ocean that contain floating plastic that has accumulated over decades. In 2018, the Ocean Cleanup estimated that there are 80,000 metric tons of garbage in the floating patch, with 1.8 trillion pieces of plastic. The plastic can end up in the stomachs of marine animals, which allows it to enter the food chain. You can see in the image circled those garbage patches. Here's the western and the eastern. Radioactive waste. An interesting example of waste and degradability is radioactive waste. All radioactive materials decay naturally over time, becoming less radioactive. Eventually, this waste is no longer radioactive and therefore no longer harmful. This process can take anywhere from a few hours all the way to thousands of years, and therefore it is important to dispose of it properly. In the US, there are 5 categories of radioactive waste: high-level waste, transuranic waste, uranium and thorium mill tailings, low-level waste, and technologically enhanced naturally occurring radioactive material, or TENORM. High-level and transuranic waste. High-level radioactive waste includes used nuclear fuel from nuclear reactors and waste generated from the reprocessing of used nuclear fuel. Usually, this type of waste is stored at the site where it was created. Transuranic wastes refer to laboratory-created radioactive elements that have an atomic number of 92, that of uranium, or higher. They are also produced from recycling spent nuclear fuel or during the production of nuclear weapons. Uranium and thorium mill tailings. Uranium or thorium mill tailings are the sandy process waste materials from mining. During the mining process, ore is ground into a fine sand. If allowed to sit above ground, the sand can be carried great distances by wind, where it can enter the food chain. Tailings must be managed properly because they could contain significant amounts of radioactive elements. Tailings are stored in tailings management facilities, TMFs, where generally they are stored underwater for a very long time. The designated ponds in which they are stored are called impoundments. They are stored underwater to prevent oxidation, provide protection from radiation, and to stop dust from blowing away into the environment. So we can see the tailings from the mill buried deep under the water here. Okay, and the water comes from this pump and up and goes to the mill for treatment to remove any waste product that may be there. So this diagram shows the movement of the tailings to the impoundment, that underground storage. Low-level waste. Low-level waste is anything that is not high-level waste or tailings. This can include everyday items like cardboard or protective clothing that has come into contact with radioactive substances. This type of radioactive waste is disposed of in special facilities. Here is an image of one such facility used to store low-level waste. Low-level waste is stored behind soil and within concrete vaults. So this is behind or underneath the soil and then surrounded by concrete. TENORM. Technologically enhanced, naturally occurring radioactive material, also known as TENORM, is found naturally in the earth. This is radioactive material that was once underground, but was unearthed by human activities like mining, oil or gas drilling, and water treatment. Fracking is a process that can release TENORM into the environment.